Hello everybody and welcome to another Mystery Box Function Challenge. In the purple box there is some math and your challenge is to figure out what it is. Because today is Friday, that math is going to be particularly challenging. You can use the link in the description if you want to try this on your own, and when you've got an idea, come on back and see if we get the same thing. All right, let's start with a 0. All right, 0 is 1. How about 1? And 1 is also 1. This is giving me flashbacks already to the last couple of challenges. We had x to the x power and x to the negative x power, and those were 2 points on there. I'm going to put in 1/2 and see what we get. And that just dips down a little bit. Okay, so maybe we have something similar to that. Let's keep going out further. Okay. Those decimals. Just taking a look and seeing if they're repeating. It doesn't look like they are, actually. Interesting. Okay, so that's something to know. How about a 3? Oh, now we're down again. So maybe this is trig. Although, why are you getting a 1, plain old 1 at 0 and 1? Let's try a 4. And a 5. And a 6. And a 7. Ooh, that's going up fast. How about an 8? Wow, this is a really interesting one. And I'm just going to throw in a 9 here. And now we're suddenly back down again. That is one of the stranger shaped graphs we've seen. Let's try a couple of negative points. Oh, not a number. Okay. So we're getting lots of not a number errors for our negative values. Well, let's just speculate with what we have on the screen over here. We've at least got enough of a shape. In the very beginning, I was thinking maybe this is in that pattern of exponentials because we've been having some of those as challenges for the last couple of weeks. And those points 0 and 1, anything to the 0 power is 1. And then 1 was also 1. And then the non-repeating decimals and the fact that it goes up and down makes me think of a trig function, either cosine or sine. Boy. So what if, and look at how steep this is. So this portion does look like an exponential curve. What if it's the sine and the exponential put together somehow? So maybe something like x to the sine x. Could that be a possibility? So let's think about what that would be. The sine of 0 is 0, so that would be x to the 0, and that'd give you 1. So that would make sense for this point. Oh, and then the sine of 1 is some decimal, but if you put in 1 for x, that's going to come out as a 1 no matter what power you put it to. So that does make sense for the first 2 points. I'm wondering if there's a value we could put in here that would help us. A lot of these are difficult to sort of calculate in your head. Let's just put in pi, or an approximation for pi, and see what we get. Aha, so there we're close to 1, and that actually helps a lot because the value of the sine of pi is 0. So in fact, every multiple of pi should give us something close to 1 on this one. Let's try 6.28. And that's basically one as well. Okay, so I think I think we've got this. Just from looking at the shape, I came up with this idea, and it does seem to be fitting. I don't think I'm going to bother to calculate any of these in between points. I think we're going to gamble on this one, and I think we probably have it. Can reveal this. Yeah, x to the sine of x power. Let's graph this. I'm so curious. Wow, what an interesting and beautiful function. And so it must, as it goes on, this part gets steeper and steeper, and it keeps going up and down, up and down. This would be a cool one to look at, graphed out much further on the graph. So if you've got a graphing program and you have a chance to do that, you might want to take a look at it. Well, how did that go for you? I think that was crazy difficult. Another question, why do you think we're getting not a number for all those negative values we put in? I'll leave that one for you to figure out. Thanks, everybody.